Hello, welcome to the trig review here. We're going to be looking at the three trig ratios that we've seen in the past, and they're going to come up again later on in one of our future units. So we have the phrase SOHCAHTOA, which is a mnemonic to remember specific words. So our three trig ratios are sine, cosine, and tangent. These are the abbreviations for them. So SOHCAHTOA stands for sine being the opposite hypotenuse sides, those are sides of the right triangle that we're going to talk about below. Cosine stands for adjacent hypotenuse, and tangent, we use the opposite and adjacent sides. Okay? So if we look at this triangle over here, notice how I have all three sides filled in. I have a right angle, and I'm going to be using these trig ratios for right triangles specifically. And then I also have my angle here, which we call theta. It's just another version of a variable similar to x. So to label the sides, because we have opposite, adjacent, excuse me, and hypotenuse, the side across from the angle that it doesn't touch, we call that the opposite side. The side next to the angle is the adjacent side, because the word adjacent means next to. And then the side across from the hypotenuse, if we're looking, the side across from the right angle is what we call the hypotenuse. This side always has to be the biggest angle. It is true that the hypotenuse and the adjacent side are both next to theta, but because this is the longest side and it's across from the right angle, we always consider that to be the hypotenuse. Now, if I want to find the ratios for these, like if I wanted to find the sine of theta, cosine of theta, and the tangent of theta, I'm only looking at the sides in like fraction form, so a comparison between the two sides. If I want to find the sine of theta, which is opposite over hypotenuse, I take my opposite side of 4 and my hypotenuse of 5, and I create a fraction. So 4/5 would be the sine of theta. I'm going to do the exact same thing for cosine and tangent. I'm just going to be using different side comparisons. So cosine is adjacent and hypotenuse, which would be 3/5, adjacent divided by hypotenuse. And then tangent is opposite over adjacent, which is 4/3. So that's how you would do these when you're just trying to list the ratios. Now, the purpose of why we teach you the ratios with trig, the sine, cosine, tangent, the main application is to find missing values on a right triangle. So here, notice how we know an angle of 32 degrees. We also know this side of 13, but we're missing these two sides. And we can't find them using other methods like we've used the Pythagorean theorem, because you need multiple sides in order to utilize that. So instead, we're going to use trig. Looking at the sides, let's go ahead and label these. Here's our 32. The side across from the right angle, that's our hypotenuse. The side across from our given angle is the opposite, and then that leaves the 13 to be our adjacent side. So here, I want to consider, well, if I want to solve for x first, x is the opposite side, 13 is the adjacent side. If I go back up to my trig ratios, which one uses opposite and adjacent? And it's tangent. So we're going to be using tangent to set this up. So tangent of our angle, which is the 32 degrees, is going to be equal, and again, we want to set up a fraction on the other side. The opposite side is x, the adjacent side is 13. Our goal now is to get x by itself. So notice how we're dividing by 13 here. So all we want to do is multiply both sides by 13. And that reduces down, and it leaves us with just x equal to 13 times the tangent of 32. Now, tangent of 32 is just something we can type into our calculator. It's going to be a decimal, and then we're going to multiply that with the 13. So let's go ahead. I'm going to pull up my calculator here. So to type this in, I'm going to type in 13. Actually, before you type this in, though, really quick, if you're using the Calculator Pro, I want you to hit this button that says Mode. It's right here next to the second button. Make sure that in your calculator you have it set to degrees and the radians part is not highlighted. Otherwise, this isn't going to work. It's going to give you a wrong answer for what we're trying to do here. So then hit second mode again. It'll bring you back to the home screen. So now when I type in 13 times the tangent, 32, and your sine, cosine, tangent buttons, they're all in the middle here, I get 8.12 if I round to 2 decimal places. So approximately 8.12 is going to be our answer for x. Looking at the side lengths here, that seems like a reasonable answer, because the other one was 13, 8.12 isn't too far off. And it looks like that should be the shorter side. Next thing that we want to look at here is we want to find the y. So that is the hypotenuse. So now I need to use a different ratio. I can use the adjacent side again, because I know this side's 13. But if I want to find y using trig, I need to go up and find the one that uses adjacent and hypotenuse. That's cosine. So now I'm going to do cosine. Slide this off for a second. Cosine of 32 is equal to, my adjacent is first, so 13 over y. Now notice how the variable's on the bottom this time, but we're still going to repeat the same step where you multiply by the denominator. So I'm going to multiply by y on both sides, because now my y's will reduce and I can get rid of the fraction. So I would have y times the cosine of 32 is equal to 13. And that's just a decimal we can divide by. So cosine of 32 is what I'm going to divide by on both sides. Y equals, and then I'm going to type this in. You have to make sure you type it in the correct order on your calculator. 13 has to go first. So 13 divided by cosine of 32. And it comes out to be about 15.33. If I set that equal over here. 15.33 is a very reasonable answer because the hypotenuse should always be your biggest side. All right, last example here. So this one, we have multiple triangles, multiple right triangles specifically, in the same diagram. So we have a side down here on the bottom, which is y we want to solve for. We have x kind of in the middle. It's a part of the medium-sized triangle and the smaller triangle. And then we also have this length of 12, which is on the medium-sized triangle. Let me just show you how far that extends. Okay, so imagine that 12 is going from the tip of the triangle to where they meet right here. So now what I want to fill in is some other information I know about the angles. I know that this angle up top is 14, and if you remember rules about triangles, the interior sum of all three angles has to add to 180. So this is 90 here, and if that's 14, by subtracting these two values away from 180, we're left with 76 degrees right here. Also, since these two form a right angle, these angles right here, that would make this one 14 degrees, so we see that again, and that would make this angle over here 76 degrees. But now that we have a side length and we know some information about the angles, all we need to do is set up a trig ratio and we can solve for our variables. So the first one I'm going to solve for is x. I know that 12 is a part of this medium-sized triangle, and I'm going to try to solve for x by using what would be the adjacent side, because I'm going to look at 14. This would be my adjacent, x would be my opposite. So here I can do tangent. I'm going to do tangent of 14 is equal to opposite over adjacent, and now I have it set up. So here, since 12 is on the bottom, you multiply both sides by 12, and whatever 12 times 14, tangent of 14, excuse me, is in the calculator, that's going to be our answer. So that comes out to be really close to 3, 2.99, or if you just want to round that up, it's really close to 3, so I'm fine if you round that there. So that means that this side length of x is equal to 3, or really close to it. So now we got to find y, but now that I know this side, I can use the other angles in the small triangle to find the third or the second side. So here, if I'm looking at 14 again, that would make x my adjacent and y would be my hypotenuse because it's across from the right angle. So then I want to use cosine for this one. So I'm going to do the cosine of 14 is equal to 3 over y. And now this time the variable's on the bottom, but I still multiply both sides by y. I end up with y times the cosine of 14 equals 3. I'm going to divide by the cosine of 14 on both sides. So 3 divided by cosine of 14 comes out to be about 3.09. Now I know that's really close to the answer we got before, but this is the hypotenuse, and it is bigger technically than our long leg there. So 3.09 does seem like a reasonable answer for that. So make sure after you get your values, consider, does it make sense? Is it the biggest side? Is it the hypotenuse? Or should it have been smaller? So hopefully this helps.